Despite the many discoveries of the genomic era, much of the human genome remains unexplored. Beth Israel Deaconess Medical Center scientist John Rinn has spent his career looking for the missing pieces. Together with colleagues at the Broad Institute, he recently identified a large group of new genes called lincRNA.
When the human genome sequence finally came out, they were surprised that most people thought only 5% was conserved and therefore probably functional. And they thought 95% was probably junk. But there was a lot of other people who thought otherwise and really wanted to go explore and investigate what that other 95% might be doing.
Rinn believed this 95% of supposedly inexplicable molecules were anything but filler. Although none of these molecules appeared to have any function, Rinn was convinced that they must have a biologically meaningful purpose.
I spent 2 years developing a technology that would allow us to look at these other regions, and it was very rewarding because we found indeed these are not junk regions and they're full of mysterious non-coding RNA molecules.
6 years after graduate school and his first observations of these RNA molecules, Rinn says his discovery of the lincRNA that came to be known as hot air was like striking a gold mine.
I like to think of it as kind of a modern-day Wild West adventure to go find gold. I think we've finally developed sifting pans that have allowed us to take this thought that the entire genome makes RNA on every base and found a pan to sift out the gold from this dust cloud.
For years, the central dogma of biology has been that DNA serves as a blueprint to make messenger RNA. These messenger RNA then make protein-coding genes that move around the cell to make sure the cell is doing its job properly. But as more and more classes of non-coding RNA are being discovered, Rinn says this thinking has become blurry as they found non-coding RNA that regulates the proteins themselves or regulates the DNA.
There's been a shift in the sense that a lot of people are now starting to look at RNA molecules themselves and what they could be doing. So instead of this simple flow of information from DNA to RNA to protein, we're seeing it move back and forth in all different directions. And this has really made us understand that the complexity of the genome is probably deriving from both protein-coding genes and non-coding RNAs that may be regulating them.
The human genome still has many tricks up its sleeve, and this recent discovery of RNA-based genes may have great implications for medicine. Based on this discovery, scientists are rethinking therapies for certain diseases, including cancer.
We've already started preliminary studies where it's very clear that a lot of these RNAs are misregulated in disease, and if they are regulating DNA, we could one day hope to engineer RNA molecules to go shut off these misbehaving genes so that we can revert the disease state back to its normal genomic architecture.